function and their graphs. What is the meaning of the rational function? The rational function is a function, but it has two polynomial functions. It has two polynomial functions, like x minus So the properties here of the rational function that it will be like f of x, it's equal any polynomial over polynomial. This is a rational function. Now, this type of the rational function, that's how we used to be say in the reciprocal function, like when you say 1 over x minus 1. If I want to draw it, I will draw it, but except at point 1, we have an it will be continuous except the 0 of the numerator, which is 1. Here is the same for the polynomial. When I want to draw the graph, I have to know that the domain now, it will be all the points except the q of x. Where is the q of x? Made the function 0. Here the function will be discontinuous. Let's see how here. This one. Here now, it's an example of the rational function, where this is polynomial function x squared, and down also we have another polynomial function. As you see here, if we know, say that the numerator, as name it as m, and the denominator as n, and the numerator, we'll name it as m. If you look here at the power of the numerator and the power of the denominator, it is the same. It's equal, squared over squared. So the first step now, I will look at the denominator. It is x squared plus 1. Okay? If you look at here now, what is the point that makes the denominator 0? Is it 1 or negative 1 or 0 or 2? What are the points that make x squared plus 1 equal 0?
Negative 1.
No point.
Negative 1?
Even if it's negative 1,
No point.
There are no real points. Times
There's no-
0.
even if it's negative 1 and then it's squared, it will become positive.
It will be
There are
an
no
imaginary
real points.
Look here, there's no points. Why? Because if you put the negative 1 on the other side, x squared equal negative 1. And x squared, it cannot be negative because its domain is from 0 to infinity. It cannot be negative. So because of that, there's no 0 of the denominator or of the function. Okay, after that now. This,
So there is the domain all the numbers.
please can you repeat?
So the domain is all in numbers.
Yes, exactly. So here, the domain now will be all in numbers, but before that, since now there's no points of discontinuity, because there's no 0 of the denominator, there's no 0 of the function. So I can say that there's no point or points of discontinuity. Why? Because if you look at this graph here, the graph will be continuous. Because the domain here is all real numbers. Why it's all real numbers? Because if you look down, there's no 0, there's no points that makes the function 0. Oh, no, there's no points that makes the function undefined. So it will be continuous. When I want to draw it, it will be continuous graph without any break, without any hole. So the graph will be continuous. So I say now there's no points of discontinuity, and it will be a continuous graph. Here the graph is continuous, as you say. It's not stopped. There's no asymptotes for it. So it will be a continuous graph. And there's no points of discontinuity. Why? Because how can I know? I will go down to see the denominator. Is there any point that make the denominator 0? No. So because of that, I can say that there's no point of discontinuity. The graph will continue. Continuous graph, it means that the graph will continue without any stops, without any hole. When I want to draw it, I will not remove my pen. I will continue to draw it. That's why we call this continuous graph, and there's no point of stop. And the domain now, it will be all real numbers. Or you can write it as like this. What about now the second graph here? For this one here, it was x squared plus 6x plus, let's say plus 5x plus 6. This was the function. Okay, it was x squared plus 5x plus 6 over x plus 2. You have like this type of function. What about the power?
You will factor it.
And
Yeah,
here you
we
have
need to factor it.
yes. So here now you have a quadratic over linear. I mean that the exponents or the power of x squared is greater than x to the power 1. So m now it's greater than n. The numerator it's greater than the denominator. The degree of the numerator is greater than the degree of the denominator. Okay. The first step now, I have to factor the numerator. It will be x plus 3 times
And x plus 2.
And down the denominator, it will be x plus 2. Now, I can find the common factor, which is x plus 2, or I can simplify the function. So what did I do here? Did I remove a function, or I cannot remove it?
We can remove it.
We can remove it, yes. Since now we can remove a function, I can simplify the function. I can say it as removable. I will tell you something later here. I can say it because since I remove the function, I call it a removable. Now, is there a point that makes the graph discontinuous?
No.
Yes. Yes, negative
At -2.
How can I know? I will go down to again. So I'm sorry. So to make now the point, to know that if the graph will be continuous or not, I will look down. I will go down, sorry, and look at the denominator. Is the denominator here? Oh, is there a point you can make a denominator 0? Yes.
Yeah, negative 2.
At point x is negative 2. At point negative 2, the graph can be discontinuous. Okay, so the point of discontinuity is at x equal negative 2. Okay, in the previous one, there's no point of discontinuity. Why? Because if you look at the denominator, there's no point can make the denominator 0. Since now that there's no point to make the denominator 0, so there's no point of discontinuity. There's no point of discontinuity, so the graph will be continuous, as we say, so. But here now, there's a point. I will go to the first step. I will ask myself, Is there a point that makes the numerator 0? Yes, there's a point. Since now there's a point that makes the denominator 0, so there's a point of discontinuity. Now, this is the first step. Since now I can make it the graph now has a discontinuous point. Now, then after that, I will ask myself the third thing, that can I simplify the function? Yes, since now I can simplify it, so I can remove the function. Since I remove the function, I will name it as a removable, but removable discontinuity. The third one now. Here now, x plus 4 over x minus 2. The first step, I will go to the denominator. Sorry. Here, but I want to tell you something now. Later on, I will tell you how to graph this type of rational function. But as you see here, if you simplify it, it will be x plus 3. It becomes like linear function, but at x equal negative 2, I will find a hole. As you see here.
So what do you mean? Blushing effect.
Here now, I want now to graph it. Later on, I will tell you how can we graph the rational function. But if you look here now, is it like we say that after we factor it, it will be x plus 3 over x plus 2 over x plus 2. So if I want now to graph it, sorry, the first step you have to simplify. So it will be x plus 3. But I cannot draw it like linear function. Why? Because the denominator told me you have to stop. You cannot draw it as a linear function. Why? Because I told you that you have a point of discontinuity. My graph will not be Did you hear me?
No,
Yes,
no.
yes, now we can hear it.
So here now, if I want to graph it, he told me, okay, you want to draw it as a linear function, you can, but you have to know something. You have to stop, because I told you that my function is a discontinuous function. It has a discontinuous point. Where is it? It is at point negative 2. At point negative 2, you have to stop.
But teacher, he stopped at negative 2, 1.
Because here, the 0 of the function is negative 2. Should we say that the point of discontinuity is at x equal negative 2?
Yeah.
Okay, so because it is the point of discontinuity at x equal negative 2, so at point negative 2, you have a hole. This hole makes that you can draw it as a line, but at this point, you have a hole. You cannot draw it as a linear function. Now go now to the third function here. Here now, when y equal x plus 4 over x minus 2. Now here, the first step I will ask myself, is there any point that makes the denominator equal 0?
Yes.
Yes, 2.
Yes. Look at x equal, I'm sorry, the denominator was, of the function of it is x minus 2. So at x equal 2. At x equal 2, the function is what here? It will be have a 0. Or the graph now, it will be discontinuous at this point. Why discontinuous? Because the function can be 0 at point 2. So I can say that the graph has discontinuous point at x equal 2. Now, the third step, I will see now. Did I remove any function? Can I simplify the function here?
No.
No.
No, I cannot simplify.
Teacher,
Yes.
can you explain again what you mean about the discontinuous point at x equal to, like in the graph that you said about -2, why they stopped at -2, 1, not only -2?
Here it's because of the horizontal and vertical asymptotes. See, but later on in problem 4, I will tell you how to sketch this type of hyperbola. Because here you will find the vertical asymptotes, you will find horizontal asymptotes, and later on you have to draw. Just now, I want you to know where's the point of discontinuity. Is it a continuous graph or not discontinuous graph? It is a removable or non-removable. By now, until now, I want you just to know how can I find or how can I know the points of discontinuity. So, this is a discontinuous point at x equal 2. So, it will be a discontinuous graph. It is a discontinuous graph. It has a discontinuous point. Now, can I simplify it here? I cannot simplify it. Since now I cannot simplify the function, so I didn't remove any function. Since now I cannot remove any function, I will name it now as non-removable discontinuity. Why it is discontinuity? Because I told you that it has a discontinuous point. And why it is non-removable? Because I cannot remove any function or I simplify any function from the numerator with the denominator. So here, if you want now, if I summarized for you here this what I told before. The rational function graph, it could be continuous graph, as we said before. It is continuous graph without hole, without any asymptotes, and could be discontinuous graph with asymptotes or with a hole or with a break. Now, the continuous graph. So until now, it could be discontinuous and discontinuous. For the continuous graph, such as the first example, x squared over x squared plus 1.
No number can make 0.
Yes, since now we cannot make, the denominator cannot be 0 because there's no point can make the denominator 0 because there's no value of x makes the denominator 0. So because of that, there's no point of discontinuity. No with discontinuity. No of discontinuity. So it means what? It means it's a continuous graph. Now, so because there's no point of discontinuity, it is a continuous graph. So the domain now it will be all real numbers. There's no point, I have to stop on it. Now let's go to the discontinuous graph. This discontinuous graph, it means that the graph will not continue at all the points. It means that the domain cannot be all the real numbers. there's a point, can make this this graph discontinuity. Now, for the discontinuous graph, I can now classify it into removable and non-removable. How? By doing the previous steps. I look at the function. Can I simplify it? Can I remove up function or up? Sorry.
Yeah,
Can I
for the
remove
first one,
something
yeah.
from a numerator with the denominator? Yes. Since now I can remove, I will name it as removable. And here now I cannot remove function from the numerator with the denominator, so I will name it as non-removable. Then after that, I will go down now to the denominator here. At point x equal to, there I have a discontinuous point, a removable point. Here at x equal 3, we have a removable point or discontinuous point. And the domain now, it will be all real numbers except 2, and here all real numbers except 3. This is now a summary for our part until now. For what did I say? Thank you for listening. Tomorrow, inshallah, we'll continue the lesson.
Thank you.
Thank you.
Thank you for listening.
Bye-bye.
Bye-bye.
Teacher, I want to ask a question. In the homework, can we submit it at this Saturday or the next Saturday?
This Saturday.
Next? Okay.
No, this one.
Teacher, we
No,
solved
this
all
one.
the questions of the worksheet.